multiplexed lower order address bus and data bus of 8085 can be demultiplexed. So let's start with our topic. We know that in the 8085, the address bus, it is of 16 bits. So these 16 bits, they are denoted from A0 to A15. And the data bus, it is of 8 bits, starting from D0 to D7. So the 8 bits, they are denoted like D0, D1, D2, D3 till D7, and 16 bits, they are denoted like A0, A1, A2 till A15. So this address bus, it is divided into two parts. First is lower order address bus, and higher order address bus. So these 16 bits, they are divided into 8 bits, 8 bits lower order address bus and 8 bits higher order address bus. So lower order are from A0 to A7 and higher order they are from A8 to A15. Now this lower order address bus and the data bus, they are multiplexed. Multiplexed means the 8 lines, they are used as both the data bus and the lower order address bus. So they are combined and denoted as AD0 to AD7. This is the multiplexed. So these 8 bits, they can be used as both the lower order address bus and data bus. Now how the microprocessor, it will differentiate that the data which is available on these lines, it is either the lower order address or either it is the data. So these multiplexed address bus and the data bus, they has to be demultiplexed. We have to differentiate that this data, it is the lower order address, and this data which is available, it is the data which we want in the program. So how this demultiplexing of this bus AD0 and AD7 is done, let's study it. Now, when we study the timing diagram for the machine cycles, there are 5 machine cycles in 8085: opcode fetch, memory read, memory write, input output read, and input output write. So these 5 machine cycles, there are timing diagram, and in the timing diagram we see that the higher order address is available on this higher order address bus for 3 clock periods. So when we draw the timing diagram, we have the T states. T states are equal to 1 clock period. So this is T1, T2 and T3. These are the T states. And when we draw the clock, so clock is what? 1 clock is equal to 1 T state. So we have this is 1 clock, and when we draw the higher order address bus here, that is A8 to A15, So this bus, it is going to have the higher order address for 3 clock periods. When we have the fourth clock period, T4, this higher order address, it is lost. We can write here unspecified. So after 3 clock periods, this higher order address is lost. So this higher order address is available for 3 clock periods, and when we have the lower order address, this is lost after 1 clock period. So this lower order address, which is AD0 to AD7, so this lower order address, it is lost after 1 clock period, and higher order address is available after 3 clock period. So there is a need to latch or to make this lower order address available to the microprocessor for 2 or 3 T states, so that the microprocessor can combine both the higher order and the lower order address and can get the combined address of the memory location. Suppose if a memory location is having the address 2034, so 20 it is the higher order address, and 34 it is the lower order address. So 20 will be available on this bus and 34 will be available on the lower order address. So if this lower order address, it is lost after 1 clock period, so the microprocessor will not be able to get the complete address if it want in the second and the third T states. So this address has to be latched, or it has to be, some mechanism should be there so that it should be available to the microprocessor. So first thing is to demultiplex both the lower order address bus and the data bus, so that we can differentiate that whether it is a lower order address or it is the data, because both the 8 lines, can be used as the address bus also and data bus also. And also there is a need so that this address is available after 1 clock period also. So there is a mechanism in 8085 for the demultiplexing of the lower order and address and the data bus. Let's see the circuitry for it. So this is the circuitry for the demultiplexing of the lower order address bus and the data bus. You can see here we have the higher order address bus available. We have 8 bits of the higher order address bus starting from A8 to A15, and all the lines at the output also we are getting the higher order address. Now as the lower order address bus and the data bus, they are demultiplexed, so we have from AD0 to AD7 we have the 8 lines here, and these 8 lines are given as an input to a latch which is 74LS373. This is the IC for this latch, and this latch, because latch is a tri-state device, there are 3 lines in it, one input, one output and one enable line. Now this latch, it acts as the D flip-flop, and whatever input is given to it, the output is the same. Okay, and there is one enable line. So when this enable line is high, that means its value is 1, then this latch is active. Means this latch is going to work when this enable line is 1. Otherwise, it will not work. Okay, now the input to this latch, it is the multiplexed lower order address bus and the data bus, and when this latch is working, like when it's enabled, it will be enabled when this address latch enable this signal, it is active. So when the value of the ALE signal is 1, then this is the enable line of the latch. So when this is high, this latch will work, it will be enabled, and whatever input is given to it, the output will be the same. That means the output will be latched for the next clock period, that is for the next time when this ALE signal is again high. When it is high, the input, the output will change according to the input, and it will be latched until the next clock cycle or until the next time this ALE signal is again high. And when this enable line is low, that means its value is 0. Low means its value is 0 and high means its value is 1. So when its value is low, 0, this latch will not work because its enable line is low. So whatever input is available here, that is the data. So we have differentiated that when address is available on that and when data is available. When ALE signal is high, then a lower order address is available here. This is the lower order address. And when this ALE signal is low, then data is available on these lines. This data is of 8 bits starting from D0 to D7. So let's have it's working. So let's have the key points of the demultiplexing, that the ALE signal and the latch, they are used to demultiplex the bus AD0 and AD7. Here we have used the ALE signal and this latch 74LS373. So this latch and ALE signal both are used to demultiplex the AD0 and AD7 to AD7 bus. Now this bus is connected as input to the latch. We can see here, this is the latch, and this multiplexed AD0 to AD7 bus, it is given as an input to the latch. Then ALE signal is connected to the enable pin of the latch. You can see here this ALE signal, ALE's full form is address latch enable. Address latch enable. This signal is especially used for the demultiplexing. That is why its name is address latch enable, because it is enabling this address latch which is here. It is connected to the enable pin. That is why its name is address latch enable. So ALE signal is connected to the enable pin of the latch. Then we have the output control signal of the latch which is grounded. You can see here we have the OC bar, active low signal, which is connected to the here as the ground, which is grounded here. Now when the ALE is high, it means its value is 1. So the latch is transparent. Transparent means whatever input is given to it, it will be its output. So the output, it is changing according to the input. You can see here means the output changes according to the input data. Let's take an example so that you can clearly understand that how the output is changing. This is we have divided a clock period here. This is clock pulse. Okay, now we have an input here. Now when latch is connected, it means that output is what? We are giving here a signal. Now according to that signal, that when this signal is high, the output will be latch. Otherwise the input, it will remain the same. Output will change according to that. Now here we are giving this input, so whatever be the input, the output will change accordingly up till this point. Now when this it is low, this output will be retained until the next ALE signal. Now next ALE signal is again coming here, so output will change according to the input. Now here again ALE signal is becoming low, so this input, it will be, this output, it will be retained until next ALE signal. So this is how the output will change. That means it is latched at these points wherever we are getting the signal. Okay, so in this case also we have the lower order address bus and data bus, it is connected here. So when this, it is, we are giving the input, the latch, when it is available, it will show the output whatever be the input, like whatever input we are getting here, like it's 10001, these are 8 bits, so these 8 bits will be available as the output. Now when this is disabled, that is means its value is 0, this ALE signal is low, the output will remain the same, it's not going to change. So again we are getting the lower order address. So on these lines, always the lower order address will be available till 3 clock periods, because we have seen that the lower order address, it is vanished, it is not available on the bus after 1 clock period, but the latch, it is going to get it available till 3 clock period, so that the microprocessor can combine the higher order and lower order address, so that complete address of the memory location is available with it. And also we have separated the lower order address bus and the data bus. So it's written here in the key point that when the ALE is high, the latch is transparent, means the output changes according to the input data, and when the ALE is low, so the data byte is latched until the next ALE, and the output of the latch represent the lower order address after the latching process. So this was the how the demultiplexing of the lower order address bus and the data bus is done using the ALE signal and the latch 74LS373. This is the IC number for the latch. So I hope this topic is clear to you that how the demultiplexing is done in 8085. Thank you.